Okay, so today we're going over negative bases and exponents. So, negative bases and exponents. Last time we covered fractional bases and exponents. This time we're going over negative bases and exponents, and in the next video we'll just go through a bunch of examples of a combination of both negative bases and exponents and fractional bases and exponents. So let's start off just with an example and just head right into it. So let's say I have negative 2 to the exponent 3. Okay, the way we're going to deal with this is pretty simple. We're going to be doing what we have kept doing ever since the beginning of discovering exponents. So we're just going to take negative 2 and we're going to multiply it 3 times, okay, by itself. So in this case, I have negative 2 times negative 2, which gives me positive 4. Positive 4 times negative 2 is negative 8. I can do the same thing with something like negative 2 to the exponent 4. And I'll end up doing the same thing, just multiplying negative 2 by itself 4 times. And in this case, we'll get negative 2 times negative 2, which is positive 4. 4 times negative 2 is negative 8. And negative 8 times negative 2 is positive 16. So we get 16. Okay? Now, before we continue, quickly want to address kind of what's happening here. So you'll see that our numbers, negative 8 and 16, if we just take a look at the number, we don't look at the sign, so we're not considering this negative. So 8 and 16, these numbers are the same as if we were to have positive 2 to the exponent 3 or positive 2 to the exponent 4. So their value, this is called their absolute value. So if we're taking something without the sign, their absolute value is the same as if it were a positive base here. So 8 and 16. The only difference being now, of course, that there's a negative in front of this 8. And you can imagine that if we were to continue this and go to negative 2 to the exponent 5, again, we would just be multiplying negative 2 by itself 5 times. And in this case, we know what negative 2 to the exponent 4 is. That's positive 16. So for these first 4, I don't have to do them. So I'll get positive 16 times negative 2, which is going to be negative 32. So what we can tell here is that these numbers are going negative, positive, negative. The next one is going to be positive. The one after that is going to be negative. So before we kind of continue, is there a way to kind of generalize this? Well, there is. What we can say is that if I have a base that is negative, okay, so a negative base, and it's raised to the exponent, and that exponent is an odd number, that means my answer is going to be a negative number. And if I have some sort of negative base and I raise it to a positive number, or sorry, not a positive number, if I raise it to an even number, then I'll get a positive answer. And that makes sense if we take a look at our examples here. So I have negative 2, okay, that's a negative base. I have an odd number as the exponent, okay, an odd number as the exponent. So I should get a negative number as my answer. And lo and behold, I get negative 8 as my answer. And if we go on to the next one, negative 2 to the exponent 4. So I have a negative base with an even exponent. Well, I get some positive number, in this case positive 16. And that pattern continues. So really, with these negative bases, we can kind of almost solve them as if there was no negative, and then just take a look at our rule here and apply that rule to our final answer to decide what the answer is. Likewise, you can also just go through the process and not really worry about the rule, but the rule is just there to kind of help you out. So let's go over one more example with a negative base. So we have negative 3 to the exponent 3. Okay, so that's just going to be negative 3 multiplied by itself 3 times. And before I even kind of solve this or take a look at it, I see that I have a negative base and an odd exponent. So if I take a look at my rule, I'm expecting a negative number. Okay, so if I get a positive number, I know I've done something wrong. I should expect a negative number. Well, let's do the math. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. So I get negative 27. So my rule works as well. Doesn't just work for a base of negative 2, works for base negative 3, and it in fact works for any negative base. Okay, wonderful. So that's what happens if I have a negative base. Now what happens if I have a negative exponent? So let's do 2 to the exponent negative 3. And in these situations with negative exponents, we're going to do something that may seem a little odd, but this is just the rule that some mathematician created with negative exponents. And that rule is that we have to turn this into a fraction. The way we're going to do that is we're just going to write it as 1 over 2 to the exponent positive 3. Okay? So when you see a negative exponent, what you're doing is you're turning that negative exponent into a positive exponent by placing this in a fraction. Okay? And once it's in a fraction, we know how to do this. In the previous video, we did fractional bases and exponents. So we can solve this. This is just going to be 1 divided by 2 times 2 times 2. Okay? 2 times 2 is 4, 4 times 2 is 8, so this is just 1 over 8. Okay? Let's do a few more examples. Let's do 4 to the exponent negative 2. So 4 to the exponent negative 2, again, we have to turn this into a fraction and get rid of the negative exponent. So we're going to write it as 1 over 4 to the exponent 2. We can rewrite that as 1 over 4 times 4. 4 times 4 is just 16. So we get 1 over 16. Really simple. Let's go over one more example, and this last example will be a combination of both a negative base and a negative exponent. Okay, so the first thing that we have to do here is get rid of the negative exponent. That's going to be the thing that's bothering us the most. So let's get rid of that first. Again, the way we're going to do that is we're going to go 1 over and then just rewrite this without the negative exponent. So negative 3 to the exponent positive 2. So we've gotten rid of the negative exponent. Now to deal with the negative base, well, we did this as well. This is just going to be 1 over negative 3 multiplied by itself twice. Again, I can use my rule, so I have a negative base to a even exponent, so this should be a positive number, but let's do the math. Negative 3 times negative 3 is positive 9, so I get 1 over 9. Wonderful. So that's as difficult as negative exponents and bases can get. Now I will mention one quick thing. What you'll notice is that in all of our previous examples up here, we have put all of these bases, these negative bases, in brackets. And there's a reason for that. If we go down here, I'll mention this kind of exception. Okay, you shouldn't see this exception too much in math because it's not really common, and you know, people don't like to write it this way. But this is something that you may experience. So let's quickly go over it. If I have something just like negative 2 to the exponent 3, this is different than negative 2 in brackets to the exponent 3. So let's go over it. We already know what negative 2 to the exponent 3 in brackets is. That's just negative 2 times negative 2 times negative 2. Okay, and we know that this is negative times negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Okay, now if we take a look at the top example, what we have here is actually negative 2 times 2 times 2. And the idea here is that this negative only applies to the first two. every additional 2 that we have is a positive 2. Okay, so that's why we sometimes, uh, you know, that's why we want to put it in the brackets, because most of the time this is what we want to express. But just so you know, if you don't see brackets, technically this is what it should look like. Now in this case, we have negative 2 times 2, which is negative 4, and negative 4 times 2, which is negative 8. So we do get the same answer. However, if we move down and do negative 2 to the exponent 4, and we do negative 2 to the exponent 4, but in brackets, you'll notice the difference. So negative 2 times negative 2 times negative 2 times negative 2, we've already done this one up there, but this one is just 16. Now if we take a look at without the brackets, we get negative 2 times 2 times 2 times 2. And what you'll notice here is that negative 2 times 2 is negative 4, negative 4 times 2 is negative 8, and negative 8 times 2 is negative 16. So in this case, we do get different answers. We get negative 16 here, and we get positive 16 here. Okay, so two different answers. And really what this is telling us is that if we don't put brackets around our base, our answer will always be negative, because we'll always have one negative number followed by however many positive numbers, however many, this exponent tells us. And if you have only one negative number and it's being multiplied by only positive numbers, then you will always get a negative number, because you're going to get a negative times a positive, which is a negative, and then a negative times a positive, which is a negative, and then a negative times a positive, which is a negative, so on and so forth, until you're done multiplying. So yeah, this is your exception to negative bases. Again, you shouldn't see this too often in math, but if you do, just remember it and keep an eye out for it. So that's everything for this video. Coming up in the next one, we're just going to go over a bunch of examples of positive and negative bases and exponents, as well as fractional bases and exponents, and it'll all be mixed up.